Recently, chess.com has made more features behind their paywall, namely the accuracy to see like the early game, mid game, and end game accuracy, and also, of course, that they already had this feature, but the ELO calculation or the estimated ELO of the game. So I thought, well, since I'm a programmer and I have access to LLMs, how hard could it be to recreate this? And it turns out that, well, firstly, Lichess has already a calculation for accuracy, right? So if we look at Lichess, they have a blog post about accuracy already and how it's calculated. This is like a older post that they had, and it uses like a single metric that they had, and they describe how it works. So at a high level, how it works is rather than just taking on like center pawn loss, they also consider some kind of human way to translate this. And as alluded, if you saw the when I was scrolling down, it is related to the sigmoidal curve, which will be very familiar to people from statistics background with like the logistic regression or like softmax and so on, like the binary softmax. And it has this sigmoidal shape. And the idea is you take the center pawn loss and you convert it to a probability. Now that you have a probability, you can then essentially average it out or calculate the mean in a particular way to then get the accuracy. Now, the good thing about Lichess is all their code is open source and you can actually just go and see how it's implemented. Now, the interesting thing is that Lichess also has a calculation for the early game, the mid game, and the end game, and that is not actually documented in a blog post, but it is in their code. And roughly how it works is, well, if you think about it from a heuristic perspective, there's a way to calculate like what's the opening, what's the middle game, what's the end game. So maybe you can do it by moves, or you can use in their implementation, what they do is they do it by like the piece count and the piece place heuristics to just estimate what it is. And they use that to then have different ways of calculating the accuracy, and then they can use that to augment and calculate overall accuracy. Now, one reason why this is important is because in the end game, where the engine can calculate exactly what the perfect move is, sometimes a human will move in ways that maybe are not optimal, but are definitely winning. And you don't want to overly penalize that. In the old approach, in this kind of approach, with the approach to taking the mean, it might actually end up penalizing the player too much, and then you end up with games that maybe have a low accuracy, but actually, well, it's still optimal play or near optimal play, or completely winning. It's simply because the end game wasn't converted as efficiently as possible. So maybe rather than converting it in like 6 moves, it converted in 20, for example. Now, that's all good and done for accuracy, but how would we estimate ELO? Now, one interesting thing with ELO is that in the last month, there was a new model that was released, which is the Maia 3 model, and it is a deep learning model. Now, the interesting thing about this model is that you can, as part of the parameters, put in the ELO for what the player is and what the opponent is inside the neural network to get an estimation of what is the likely human move that would happen. Now, this creates an interesting search problem that you can then do. I did this and played around with this via like some kind of ternary search. You can use binary search. I felt that ternary felt more natural, where you divide the segment into 3 and you figure out the bounds for where the range for where the ELO is, and you can like just go down and down and down until the increment is small enough, and you can just say, hey, it's within this range. And what I found with doing it this way is that it works relatively well. I downloaded a bunch of Lichess games where you can go and export it. I tested it on a couple of them, around 50, over a range of different ELOs, and it got the banding roughly correct. it's hard to say whether it is, because some games maybe the players outperformed and didn't outperform, and other games, the players maybe played poorly. And I didn't download any chess.com games which would have this information that you could use, I guess, to verify, but it did seem to get at least in the ballpark correct. The one thing I will say about the Maia 3 model, if you do try to implement this, is only roughly 200 lines of Python code, is that the range for the usable ELO, if you like, is around 600 to 2600, and it is trained on Lichess as well. So it's the Lichess ELO. It's not real player ELO, if you like, where there are players that have like over 3000 ELO on the online platforms. So with that in mind, like, what is Maia 3 actually? So Maia 3 is one of the newer models. It is built off the previous one, and the Maia models, if you're not familiar, are models that try to play like a human, which is why you have like a parameter there that is like what ELO has. And the Maia 3 model was actually announced only a month ago, so it is a fairly new model, and I think it is being published in ICML. And yeah, it's very interesting to see this kind of model where you can just put in the parameters for the ELO to get the prediction. Because like in the previous Maia model, what you actually had to do is you had different weights for every single ELO range. There were some interesting like demo screens that you saw on Maia 3, which you can go and look that up yourself around like heat maps and like the representation, because ultimately the purpose of this model is to try to make it look more human, and ways for how you can train yourself, of course. Now, with that in mind, I just wanted to highlight like one thing with conducting ternary research in a kind of naive way that I found, and it's been on my mind. Maybe in the future I will hack the Maia 3 codebase and improve the inference speed on this, and that is like it ends up being very slow. Because one thing with like chess.com that got me thinking is when you estimate the ELO for a game, it is pretty quick, right? But if you do this naively with a ternary search with the Maia 3 API, which I will show you in a sec, it ends up being very expensive to do it. Whereas I think there is probably a way to hack the neural network so that you can do like a massive batch like inference across a range of scores, a range of a range of ELOs, get the prediction for like the human moves, and then you should be able to narrow down the search very, very quickly rather than needing to evaluate like a full game every single time. But maybe that's a exercise for the future. So I am going to show you the codebase in which to explain what I mean. So let's just look at the codebase here. I will make this a little bit bigger, zoom in a bit. So this is a Maia 3 model, and generally the most interesting thing I look at, or I like to look at, is the forward. So you can see with the forward there's tokens, which is a tokenization. They tokenize the 64 board state, like 64 grid board state. And on top of that, as part of the tokens, there's also history. I think it is like the last 7 moves or something like that. As part of the inputs is also your own ELO and the opponent's ELO. I think like the way to improve the inference, specifically inference, is if you somehow take in tokens and a range of ELOs, so that when you do a forward pass, it will just do all of it all at once with like the board state and the ELO and so on. That's in terms of my thinking, and then hopefully as you flow through, you can just do it all in one single pass, because then again, like all the weights are shared, right? Like it's not like you have different weights for different ELOs. So yeah, that's the chess accuracy and ELO estimation. That's just an idea for how to implement it. It's probably something I'll try to optimize and implement later, and maybe I'll make a separate video. Yeah, it's something that I thought was interesting to think about, and it is always interesting to see what's the new and upcoming ideas that come out from the chess world, because I often think that like that has parallels to how other things develop. particularly in regards to human interaction with machine learning. So yeah, that's all I have for today. And hopefully next time I will actually go and implement this.